In this video, we're going to look at topic 72, example 5, determine positive or negative intervals. Identify the interval or intervals on which the function y equals x squared minus 2x minus 3 is positive. Okay, so for a problem like this, what we're looking to do is we want to solve this. So we're going to take this x squared minus 2x minus 3, and we're going to factor this, find the zeros, draw a quick sketch of the graph, and then that sketch of the graph will allow us to determine which intervals are positive and which are negative. So my factor sum chart, I want factors of -3 that have a sum of -2. So factors of -3 that have a sum of -2. There is no a value. Oh, let me fix that. There is an a value. A is 1, so we don't have to use the AC method. We can just stick with our factor sum method. So factors of -3 would be 1 and -3 or -1 positive 3. 1 -3 has a sum of -2, which is what I'm looking for. This one has positive 2, that doesn't work. So my factors are 1 and -3. So I'm going to rewrite my expression in its factored form. Two binomials, x plus 1 and x minus 3. So hopefully you're getting the hang of this by now in terms of factors. Next, we would solve using the zero product property. So I set each piece, right, each factored form equal to 0, and then solve for x. So x would be equal to -1. And over here we would add 3, so x is equal to 3. Now they're not looking for the zeros, they're asking us for about intervals. So those are not our solutions. They are the zeros, but they're not our solutions. So next I would draw a little sketch of my graph here. Doesn't have to be perfect. I know that I'm going to have a 0. Let's use some colors here. So I'll have a 0 at -1, which is going to be right here. So I'll highlight that one. And I'm going to have a 0 at x equals 3, which will be right here. So I'm going to highlight that. Now, I'm not really concerned with how narrow or stretched or compressed this graph is. I don't really care where the vertex is too particularly. What I do care about is which way the graph opens, whether it opens up or down. Since my a value here is positive, my graph is going to open up. So I'm just going to draw a graph that looks like this. All right. Again, I have no idea where the vertex actually is, or I could figure it out. I don't care where the vertex actually is. All I care about is which way the graph opens, whether it opens upwards or downwards. Since I am looking for positive intervals, I'm just going to highlight this in blue. I'm actually going to change some colors here. So I'm going to use red up here because I'm looking for positive intervals. So positive interval, remember, is anything above the x-axis. So this part of my graph here is positive. This part of my graph here is positive. This was -1. This is positive 3. So my positive intervals are when x in relation to -1, it's going to be less than -1 because we want the values that are left of -1. And the values in terms of the 3 are when the x values are greater than 3 because we're moving to the right of 3. So my positive intervals are right there. The graph doesn't have to be perfect in terms of the vertex. What is crucial and absolutely critical to getting the intervals right is whether the graph opens upwards or downwards. All right, so you have to be very, very careful with that. Since a is positive, it opens upward. So we can find out the intervals based on the sketch using our zeros. That's all for that one, and try the triad problem.